Okay, in this lesson I'm going to look at some important folds of triangles. Triangles can be folded into two separate parts along particular lines. I'm going to look at 4 of these folds that we talk about. Okay, the first one I'm going to talk about is a median. A median, first of all, is a line segment, so it has 2 endpoints. It connects a vertex to the midpoint of the opposite side. Okay, so if I look at this original triangle here, ABC, we've got a line segment here from A, and that's going to the midpoint of BC. Okay, that D is exactly halfway along. You can see that with the tick marks. So that's the median. I'm going to look at constructing that on GeoGebra. We can draw a median. So let me go bring up our GeoGebra file here. I'm going to just put in any triangle. It doesn't really matter what shape I put it in as. And there we have a triangle ABC with sides named in the usual way, lowercase letters, each side named with the same letter as the angle opposite or the vertex opposite. Okay, to construct a median, the first thing I need to do is find the midpoint of a side. So here's a side BC. I can find the midpoint of that side. GeoGebra has a little instruction here. If I look at my drop-down menu for points, I've got a list of them. Midpoint is that one. Just select it. So I've got ABC. I'm going to click on this side and it puts in the midpoint. To draw a median, I'm going to go up to my line segment menu and choose a line segment with 2 endpoints. I'm going to start here at A and finish at D. So that's a median of that triangle, and you can see that triangle could be folded across that line. Okay, it's not symmetrical across that line, but you could fold along that line if you wanted. An important thing to know, of course, is that every triangle has 3 medians. So you find the midpoint of a side, and then you connect the vertex to the midpoint of the side opposite. There's a median. Or if I put in one more median, find the midpoint of that third side, little b, and connect big B over to the midpoint of little b. That's a median. Okay? Every triangle has 3 medians. All of those medians are contained entirely within the triangle. None of those median line segments go outside. They're all contained entirely within the triangle. And note they all have a little point where they all meet. That point is called the centroid of the triangle. We'll look at that in another lesson. Okay, so the median is a line segment connecting a vertex to the midpoint of the opposite side. All right. The next fold I want to talk about is the altitude. And an altitude, again, it's a line segment, meaning it has 2 endpoints. And it's from a vertex, but it's perpendicular to a line containing the opposite side. So the key thing about drawing an altitude is that, I'm drawing it perpendicular to the opposite side. Or, sometimes the altitude will not be within the triangle. In this triangle here, the opposite side over here, AC, goes to there. And so to draw a perpendicular from B to that side is impossible. So I've kind of got to extend B a little bit further out and then draw the perpendicular to that. Okay? So that's the altitude of a triangle. And again, I'm going to show you how to construct that using GeoGebra, drawing a triangle and looking at altitudes. And again, every triangle will have 3 altitudes. But one thing to note is that altitudes are not always inside the triangle. Medians are always inside the triangles. Altitudes are not necessarily. The altitude always gives me the height of the triangle from a base. It gives me a perpendicular height from a particular base. Okay, so here this is the perpendicular height from the base AC. Here this is the perpendicular height from the base AC. But I could rotate those triangles onto different bases if I want. Okay. We also know about the relation between slopes of perpendicular lines from our work in Cartesian geometry. But for the moment, I just really want you to be able to, understand the definition and be able to construct this. So if I want to draw an altitude in here, I want to draw an altitude in here. What I want to do is I want to just take this menu here. I'm going to draw a perpendicular line from the point A. It's perpendicular to the side opposite. There's my perpendicular line. Okay, and I'm just going to mark in that point where they intersect over here on this little side. So again, go to your point menu, intersect. There's the point D, and I'm going to get rid of that big long line, so I don't need that line. So I'm going to hide it, just clicking it over here, it'll disappear, and I'm going to replace it with a little line segment. So line segment from A to D, and that is an altitude. Okay, the key detail is it contains a vertex and it is perpendicular to the side opposite. Notice that's 90 degrees. Okay, and that triangle, you know, that's in there. That's what it looks like. Okay, so that's what an altitude looks like, and you can draw an altitude from any vertex to any side. One thing I will mention, you know, if I make this triangle, let me just move some of these points. If I make this triangle into an obtuse triangle, meaning one of its angles is obtuse, my kind of altitude disappears. And so, but that doesn't mean the altitude is no longer exists. The altitude goes from a vertex perpendicular to a line containing the opposite side. So to draw the altitude here, I have to imagine this, you know, a line containing this side BC. So I can extend a line, so I'm going to go to my line menu, extend a line all the way through B and C, and then I can draw my perpendicular line from that vertex down there, and from here on in it's the same as before. I'm going to choose my intersection point. I'm going to hide that last line, and I'm going to draw in a line segment. Hide that last line, draw a line segment here, and you will see again that that's going to be a 90-degree angle in there. That is an altitude. It gives me the height, and every triangle has 3 altitudes just like before. So again, you can draw in the altitudes pretty easy. An altitude from here, again, just going to mark in the point of intersection. Key detail is it has to be perpendicular to the side opposite, and I'm going to draw in a segment and hide that big line, and there's another altitude. Note that angle in there is a right angle. So that's how we construct an altitude. The definition tells you everything you need to know. It's a line segment. It goes from a vertex perpendicular to the side opposite, or, you know, if we're dealing with an obtuse angle, from a vertex perpendicular to a line containing the side opposite. Okay. Altitudes are not always inside the triangle. Here's an altitude here from A to E that is clearly not inside this triangle ABC. They can be outside the triangle. When are they outside? Well, they're outside if the triangle is obtuse. We can get one outside. If the triangle is acute, meaning all acute angles, then we won't get one outside. They'll all be contained inside. The other thing is, if the triangle's a right angle, well, one of the sides will actually be the altitude. That line segment from A to E will be the altitude there. So for a right angle triangle, the altitude, one of the altitudes will be, in fact 2 of the altitudes will be sides of the triangle. This side from E to C here, that will also be an altitude of that triangle. Okay, so right angles, 2 of the sides will be altitudes, 1 of them will not. Okay, I want to talk about the perpendicular bisector of a side. And again, this is the stuff you would have looked at before at junior cert. This is a line, as opposed to a line segment, perpendicular to a side and passing through its midpoint. Okay, it's perpendicular to a side and passing through its midpoint. So again, it's passing through the midpoint of a side, just like the median was, but instead of going off to the vertex, it's just perpendicular to that side. It's perpendicular to that side. So let me get rid of some of this stuff, and in fact let me open a new file. Okay, so I'm going to just draw any old triangle here. Okay, so there's a triangle named in the usual way, and the size of the triangle is not important. We'll do the same thing as we always do. But to find to draw a bisector, a perpendicular bisector of a side, we have to first of all bisect the side, which means finding the midpoint. So go to my point menu, go to midpoint, pick a side. I'll pick this side, little a, and I can draw a line perpendicular to there, perpendicular to that line through that point. That is a perpendicular bisector. Okay, that is the perpendicular bisector, and it passes through the triangle, and I can do that with any side. Pick a midpoint and draw the line perpendicular to the side passing through that midpoint. Pick a midpoint, draw a line perpendicular to that side, sorry, try that again, perpendicular to that side containing the midpoint. Oh, and something's happened there, I've done something wrong. Now I'll pick a midpoint, I picked the wrong side, that's it. So pick a midpoint over here, I'm drawing a line perpendicular to that side passing through the midpoint, looks like that. Okay, notice all these lines intersect at the same point. Okay, and that point again has a particular name. It's called the circumcenter. We'll deal with that in a future lesson. But that's the perpendicular bisector of a side. You have to be able to find that. Okay, and the last thing is called an angle bisector, and this is a line dividing an angle into two congruent parts. So if I look at this triangle here, this angle up here has been bisected by this black line, and these two angles will be congruent. Okay, that's an angle bisector. That's an angle bisector. This is something called the angle bisector theorem, which says these two sides, I think we'll call them H and I there, will be in the same proportion as these two sides. And that's called the angle bisector theorem. Okay, useful thing to know if I bisect an angle. But let's look at bisecting an angle on GeoGebra. So get rid of some of this stuff. I'm just going to use my undo key here repeatedly until I get what I'm looking for. Expand that out. So to draw an angle bisector, well, I can cheat a little bit here. I'm going to, GeoGebra has an angle bisector function here. So I just pick the two sides that I want to bisect. And there we are. It puts in this one here, G, is the angle bisector. This is normal to that. Okay, and every angle will have an angle bisector. Every angle will have an angle bisector. And again, notice all those folds meet at the same place. All those folds meet at the same place. So I'm going to get rid of some of this stuff. Get rid of that one. I'm going to get rid of this one, H. I'm going to get rid of K, I think. No, that's the wrong one. I'm going to get rid of this last one over here, which is called J. Oh, I see what's... Sorry, it's... I forgot to remove it from the function, so it's still bisecting things that I keep adding on in there, so get rid of some of that stuff. And the J over there. and L over here. Okay, so there's my 3 angle bisectors drawn in. Note they all meet at the same point. That point is called the incenter of the triangle, and again we'll talk about that again, but for the moment make sure you know what they mean. Really get the definitions in, and there's no easy way to do that other than just sitting down and learning them by heart, I suppose. So angle bisector, all of these you should try folding. Cut out a piece of paper into a triangle and try using a fold to find the angle bisector. How would you do that? My next video I'll post will be doing just that, but again, before you look at that, see if you can do it yourself. Cut out any old triangle, see if you can fold in some of these triangle folds. Okay, so 4 important triangle folds. What's expected of you? Well, you need to know the definition and how to draw each of these folds. So if I talk about a median, which I will be in future lessons, you're going to have to know exactly what I mean. If I'm talking about an altitude, you'll have to know exactly what that is. A perpendicular bisector of a side, have to know what it is. And an angle bisector, you have to know what each of these things are. Okay? And really, really important. Okay? Because the next section of our course will be talking about using these folds to find concurrencies of triangles. So practice that stuff. Go over it, try the GeoGebra, try the paper folding exercise, and see how you get on. And learn your definitions.